pressure in the ventricle, so this one will close. Okay, so both valves are closed, but the ventricle contracts, so the pressure increases linearly. So up to this point, you can see that at this point, after here, the pressure in ventricle is more than the pressure in the aorta. So that means up to that point and above, pressure in ventricle becomes higher than pressure in aorta. So if pressure of ventricle higher than aorta, of course this valve will open, right? So therefore the valve will open. So when this valve opens, this is when the blood can start to flow out. So you can see that the moment when the blood starts to flow out, it's no longer increasing linearly, but it is slowing down in the rate of increase. It is still increasing, but the rate is slowing down. Why? Because the blood flows out, blood volume drops, pressure will slowly drop, even though the muscle is also squeezing at the same time. Okay? And now you can see that the red line and the blue line are in line. Why? Because this valve connecting both of them is open. So whatever pressure you have inside here is the same pressure here because it's the pressure in the blood. You introduce this pressure to the blood. So therefore both of them have the same pressure. Showing you ventricle and the aorta are both connected already. That's why they have the same pressure. Okay? So up to here is when you can see that the red line and the blue line separates. So which means to say they are no longer connected. Okay? So which means to say at this point, ventricle relaxes. That's why the pressure drops. But over here, the pressure here drops because the blood volume decreases. The muscle is still contracted, but the blood volume decreases, so the pressure drops. But from this point onward, the pressure drops because the ventricle relaxes. So it's ventricular diastole. So the moment it relaxes, what happens is that the blood in the aorta will flow backwards and hit this valve. So this blood vessel is supposed to be up there, right? I will simplify it down here. So it's up there, the blood will flow backward the moment the ventricle relaxes. So what happens is that the blood will flow backwards, hit the valve, and the valve will close. Because ventricle relaxes, pressure in ventricle becomes lower than pressure in aorta. So suddenly the muscles relaxes, the blood will flow backwards, so up there, hit the valve and the valve closes. So now the pressure on both sides will be different already, because the valve is closed. So ventricle relaxes, pressure continues to drop. Okay. So you see here, the pressure in aorta continues to drop slowly because the blood in aorta will then flow away. So as it flows away, blood volume drops. So pressure drops. So in this graph, there are only two simple things. Why is there a change in pressure? It's either because the muscle contracts or relaxes, or the blood volume increases or decreases. That's all. Nothing else. So as long as you have that in mind, before you start explaining this, it will be very easy. Because it's so easy. So easy. It's too easy. Okay, so your approach using that to explain this is the easiest. Nothing easier than that. Okay, so let's continue. So I've not explained this part here, a sudden increase and drop. The sudden increase is because when ventricle relaxes at this point onwards, there's a sudden drop in pressure here, causing the blood to flow backward, hit the valve. So the moment the blood hits the valve, there will be a sudden increase in pressure here because of Newton's third law. So therefore, it's a sudden increase in pressure, and after that, it will drop because the blood hits and then it goes away. So it hits like this and then it goes flow away. Okay? So let's look at the green color line from here onwards. We stop here to explain. So for the green color line, which is representing the pressure in atrium, the moment when ventricle contracts, the pressure in ventricle increases. So the pressure in ventricle becomes more than pressure in atrium. This valve will close. So when this valve closes towards atrium, there's a sudden increase in pressure in atrium, which is shown by this sudden increase here. So this is due to AV valve close. Okay? So after that, what happens is that atrium relaxes, but the blood flows into atrium. So when the blood flows into atrium, you see the pressure in atrium increases. Atrium is now relaxed. So it's relaxed, it's diastole, but the pressure increases. Why? Since it's diastole muscle is relaxed, pressure increases because of why? So look at that. What can change the pressure? Either diastole, systole, or blood volume. So if it's relaxed, what can increase the pressure? Blood volume. Why? Because the blood can now flow in because this chamber is relaxed. So therefore it flows in and it starts to collect because this valve is closed. So as it collects, the volume will increase, therefore the pressure will also increase. Okay? Then at this point you can see that what happens is that the ventricle relaxes, the pressure drops until it goes below the pressure of the atrium. So that means at this particular point, pressure in the ventricle is less than the pressure in atrium because ventricle relaxes. Atrium relaxes, but it's got blood in it. So because of the blood volume, the pressure in atrium is bigger than pressure in ventricle. So because of that, it causes this valve to open at this point here onwards. Point of intersection. So AV valve open. So when AV valve open, of course the blood will not be able to flow from here to here. Alright? Both of them are relaxed. So the blood flows in and what happens? Blood volume for this one drops and this one continues to relax, so both of them go down. Their pressure becomes the same because they are already connected. The valve separating them is open. So they are connected, their pressure will be the same. See? So the blood flows from atrium to ventricle, so the pressure drops. And after that, blood starts to collect. So the pressure increases again until the next atrial systole, which squeeze the remainder blood into here. Okay? So that's the cardiac cycle. It's very, very simple. So my advice is you want to learn it well, you have to know this well. Everything in here is explained based on this principle. This is the basis. Okay? So learn substroke before you jump to the sea and swim. Or else you'll be like,